Hello, folks. So, welcome to part one of learning. Okay, something went wrong with my mic. Welcome to part one of exploring and learning ML. So, I actually have almost zero knowledge, or like some basic, very, very high level knowledge of like things like machine learning. One moment, machine learning, and say artificial intelligence. Just know some terms, I guess. So deep learning, people keep using these terms. And then yeah, like models, machine learning models, ML models, or neural networks and whatnot. So I actually wanted to like explore because recently I've been hearing a lot of like cool things about, say, machine learning, artificial intelligence, and I just got curious. I've learned very basic theoretical stuff in like my college. And I tried to learn some more later through this Andrew NG course. But I stopped in between. I think I was using some MATLAB similar software and like doing some exercises and whatnot. And then finally, I was like, okay, I didn't finish it. I think it was some Udacity or some course. It was more of math and whatnot. So very low level theoretical and like proper math for ML. Around like say 2017 end or 2018 start, my friend said, "Hey, if you want to learn ML, you start from the application layer. You start applying ML, and then you start learning the math." And I never followed that, but today I asked him again, like, "Hey, so what do you recommend?" So he said he recommends this library called Transformers library by Hugging Face. It's a community. And then he mentioned this book, Hands-on Machine Learning. By O'Reilly. I think it's O'Reilly. I think this is spelling. And then he mentioned I can check out, say, NLP, Natural Language Processing, which is a good start for dipping my legs into ML. The other things he asked was around like, are you interested in like CV, computer vision, as like, oops, not vision, and similar stuff. So I was like, no, not so much. So we had a very big talk. I'll probably talk about that later. But for now, I thought, and the other thing was, I think he mentioned, yeah, I mean, this is a pretty good one, he said. He said it's like a deep learning thing, and for most popular use cases, you can do some stuff with this. I don't know what. I'm gonna have to check it out. So let me go and start off my Pomodoro timer so that I don't spend too much time at in one go. Instead, I take it in small pomodoros. So I actually don't know the difference between these three. I'm just gonna try to understand the difference again once before I move on to the other stuff. Um, Training data. There's like many terms that I learned in college. And yeah, I mean there was like many things. Yeah. But yeah, I mean for now, I think there was also different types of neural networks. I think there was CNN and some RN and whatnot, convolutional neural network. So, but yeah, these and all I just learned just like that, just the terms and like some basics of what applications it has. But now I want to like actually apply it and see how that goes in. So let's start with say Hugging Face. Or okay, let me just check out the meaning for this. So we'll start off by so I'll say tasks, ML tasks, and understand the meaning of ML, AI, DL, right? Let me go here and say artificial intelligence. Okay. So what does Wikipedia say? So what is intelligence? Okay. Can go here. Is intelligence demonstrated by machines? Cool. So they can learn and be intelligent as opposed to the natural intelligence displayed by animals, including humans. AI research has been defined as the field of study of intelligent agents as to any system that perceives its environment and takes actions that maximize its chances of achieving its goals. Interesting. So basically, I mean, it's your artificial intelligence and not your natural intelligence. You teach machines which are not some natural stuff, but man-made stuff to be intelligent. So here they're talking about maximizing some chances of achieving goals. For example, if the goal of a machine is to say play a game, the idea is to win the game. So the term artificial intelligence had previously been used to describe machines that mimic and display human cognitive skills that are associated with the human mind, such as learning and problem solving. Yep, machine learning. So you're trying to do learning or even problem solving. Yep. I love these two things, and I'm actually very curious about how do you teach machines to do that, because I've seen a lot of interesting applications. So I'm like, wow, okay. So we are using, I think we are using a lot of math, and we're just using math and trying to teach machines. I am not sure what ends we'll go if we understand how the brain like exactly works, and if we can replicate that in a machine, then I think it's just going to be crazy. So this definition has since been rejected by major AI. Okay. Who now describe AI in terms of rationality and acting rationally. Okay, which does not limit how intelligence can be articulated. Okay, so AI applications include advanced web search engines. Yeah, like even this one, like when I type artificial intelligence, the search engine is trying to understand what I just asked. Say if I ask what is artificial intelligence, it has to understand that thing, like to understand language, the English. I think it's natural language processing. I don't know. And then apparently it's some specific area called information retrieval, IR, I think in short. And they do that. And then of course they do all this. When say Google has a page ranking algorithm, I don't know what DuckDuckGo does. Something similar might be there. So yeah, web search engines, recommendation systems like Netflix and whatnot have recommendation systems. Even YouTube does a lot of that. Understanding human speech, all your Alexa, Google Home, your Siri and whatnot, right? So self-driving cars, automated decision making and computing at the highest level in strategic game systems. Yeah, I mean, I guess you would have known that there's chess. I mean, machines that play chess. I think it was IBM's Watson. One moment. Let me go ahead and open this up. IBM Watson. So Cloud Packs is developers. Okay, Watson. Think chess. So can play chess. So since Deep Blue's victory, oh, okay. So it's called Deep Blue, I think. IBM Deep Blue. So this machine, Deep Blue, was a chess playing expert system run on a unique purpose built IBM supercomputer. Awesome. So it was the first supercomputer. Sorry, it was the first computer to win a game and the first to win a match against the reigning world champion under regular time controls. So development began in 1985. Wow. CMU University. So under the name Chip Test. So active. Okay. Prototype release upgrade. Wow, okay. Workstation. Cool. That's pretty cool according to me. I mean, like you teach a computer to play a game and you make it win, you help it win. So it first played world champion Gary Kasparov in a 6-game match in 1996, where it lost 4 games to 2. Okay. It was upgraded in 1997, and in a 6 game rematch, it defeated Kasparov by winning 3 games and drawing one. So Deep Blue's victory was considered a milestone in the history of artificial intelligence and has been the subject of several books and films. Nice. So yeah, I mean, I'm not surprised like IBM talking about all this, because they have created a lot of stuff around AI, I think, like IBM Watson and whatnot. So I mean, this is a very big thing. Just want to go ahead and check out. Okay, actually, they have some interesting stuff around here. So let's go read this. Leverages computers and machines. Oh yeah. What's the difference? I mean, any generic machine, okay. To mimic the problem-solving and decision capabilities of the human mind, okay. But I thought this was not an accepted thing, but okay. A number of definitions have surfaced over the last few decades. What was the following in this 2004 paper? Okay, it is the science and engineering of making intelligent machines, especially intelligent computer programs. I mean, everyone wants this, right? Like every tool or every software that they use, they want it to be intelligent and like infer things, understand things, and like with as minimal input or yeah, basically as minimal input as possible and like as minimal commands to give so that it understands based on the history and whatnot. So it is related to the similar task of using computers to understand human intelligence, but AI does not have to confine itself to methods that are biologically observable. Okay, so yeah, I mean, you don't have to confine yourself to like say, I mean, I was talking about like replicating brain, but I guess it doesn't have to confine itself to the methods that are biologically observable. However, decades before this definition, the artificial intelligence conversation began with Alan Turing's 1950 work, Computing Machinery and Intelligence. Okay. In this paper, Turing, often referred to as the father of computer science, asked the following question: can machines think? From there, he offers a test, now famously known as the Turing test, where a human interrogator would try to distinguish between CAPTCHA, uh, computer and a human text response. While this test has undergone much scrutiny since its publication, it remains an important part of the history of AI. Okay, one of the leading AI books in our okay. In the book, they delve into 4 potential goals or definitions of AI, which differentiate computer systems as follows. Okay, interesting. So systems that think like, so the human approach is systems that think like humans. Okay, I mean, think basically systems that act like humans. Ideal approach is that systems that think rationally, systems that act rationally. Okay, but have fallen under the category of systems that act like humans. Okay. In the simplest form, artificial intelligence is a field that combines computer science and robust data sets to enable progress. So expert systems, an early successful application of AI, aim to copy a human's decision-making process. I think it's like kind of like rules based on rules. In the early days, it was time-consuming to extract and codify the human's knowledge. AI today includes the subfields of machine learning and deep learning, which are frequently mentioned in conjunction with artificial intelligence. These disciplines are comprised of AI algorithms that typically make predictions or classifications based on input data. Okay, has improved the quality of some expert systems and made it easier to create them. AI plays an often invisible role in everyday life, powering search engines, product recommendations, and speech recognition systems. There's a lot of hype about AI development. This is to be expected of any emerging technology, as noted in Gartner's hype cycle. Product innovations like self-driving cars and personal assistants follow a typical progression of innovation from over-enthusiasm through a period of disillusionment to an eventual understanding of the innovation's relevance and role in the market or domain. Okay. Lex Friedman notes his 2019 MIT lecture. We are at the peak of inflated expectations, approaching the trough of disillusionment. I'm not sure what's referring to here. It basically looks like, I mean, my friend usually tells this thing wherein they say it's just a bubble to be blown, like to be broken. Like, so I think so. One technology they said this. I don't know if they're talking something on the similar lines, but yeah, I mean, initially it's a lot of enthusiasm and then some illusions, and then at some point they'll understand, the innovation's relevance and role. As conversations continue around AI ethics, so as in like, can AI be then bad, like can do bad things and whatnot, you can see the initial glimpses of the trough of disillusionment. Read more about AI stands on AI ethics here. Okay. So types of artificial intelligence: weak AI versus strong AI. Interesting. Also called narrow AI or artificial narrow intelligence is AI trained to perform specific tasks. Weak AI drives most of the AI that surrounds us today. One moment.